How you doing? Good, how are you?
Maybe talk a little bit about comment the relationship with him.
Yeah,
And
he talked about the combo, you know, and what we do.
Yeah.
I don't know if the new people that came out at the last public night knew that we do asteroid work and other stuff. I don't know if that's necessary, but I was just thinking of some small things to.
Son of the ham radio.
Oh, have you? Okay, Brent.
Yeah. Long Beach.
I don't remember. I usually remember faces pretty good.
Yeah.
Relative?
Yeah, my
I missed the last
grandson.
one.
Hey,
He
nice
just
to meet you.
came in from Germany,
Oh,
but he's
really?
coming here to stay permanently.
Are
Yeah, they
you
bought a house and,
an American?
well, he's German. Well, his mother's.
Well,
Right, he's got a dual passport.
I don't know if he's stationed over there for military
No,
or
no,
anything
no,
like that.
no, nothing to do with
Okay,
military.
so-
No, so the family's moving here,
Oh, neat.
except his father still has to get a green card, and he
Mhm.
applied in February, still waiting, so his father's gonna have to go back.
So went to German schools and everything?
Yes.
Good.
So he's gonna start Washburn Rural High School.
And at what grade?
And then,
11th grade?
he actually speaks English.
Yeah. Better than most kids at the high school.
Right.
Because I used to
Yeah,
be
this is
principal there and I know.
Torsten.
Torsten?
Torsten.
Nice to meet you. I'm David.
Nice to meet you.
Members night is this Saturday, is that right?
Members night was last
Or public
Saturday.
night's this Saturday.
This Saturday
Public
is
night.
public night at the Clouds.
Right, I won't be able to be there. It's
Okay.
that such a good amount of time I've got the kids. Won't be much help.
Probably more fun than hanging out at Putin.
I had a good time last time.
Yeah, it was a good one. Had a lot of help and the crowd was good. Yeah, considering the tomball was down, I thought we put on a pretty good show.
We should just keep it down for a long time.
When do you need those things painted?
Whenever
With
you,
the
whenever
lights?
you get a chance.
The original.
Because I
Combo ground.
went and got the paint today.
School.
Oh,
Yeah,
Yeah, it's, that'll be probably the next stage, is to put that cage on, but
Went to,
we're not in any big rush. Still haven't heard anything from the mayor, so. And I was hoping that by the end of the month here, hear something at least that.
Plans is not working.
Well, yeah, he was
Also
apologetic,
moving
or at
along
least
quick.
came across that way, so you would think that he
Yeah.
tried to
Right,
follow
right.
up, since he goes, oh, I didn't tell
Oh,
you.
so, yeah.
No.
Yeah.
We were just about ready to call authorities.
Yeah.
She's
Your attorney general
We were about to get a knock
We
knock.
went to Katie, who's.
But the
yeah,
Attorney General.
Probably older than me. And, but the kids inside of the kitchen. I was just saying his mother actually saw Tom Ball.
Oh, really?
Went to, he was at KU,
Mm-hmm.
and the kids were little, his mother was a little kid,
Yeah.
and my daughter,
It was fun.
and I think they were pinching, they wanted to leave
They had
because
this
it's this
chili
old
dinner
man
thing,
talking,
which is new.
Mhm.
They hadn't had that before.
you know, probably younger than me.
I wasn't at that.
Mhm. Yeah, so,
Yeah, that's pretty neat.
my mother actually,
No, he's not, he wasn't younger than you.
So did your mom go to
Well,
Kansas
like, then
University?
My wife had an event downtown. She,
So your mom
So I had to-
studied astronomy, or
No.
no? They were just
she's
there.
got her degree
Yeah, I mean,
in
it's-
Russian and French.
Okay.
It wasn't.
And wanted to brush up on her
Overly hot or
Russian,
anything.
was in Moscow, and then met this German
Rainy or
guy.
whatever.
Mhm.
So,
Yeah.
they had new antennas, new radios, and
How much is gas in Germany per liter?
people seem to like it. I mean,
Was it a good turnout?
I think so, yeah. I mean, it's about what we
What is
usually
it?
had, I think. I don't remember.
$1.90?
No,
Yeah,
it's
sign up
for a liter?
It's probably something
Yeah.
that would be in the
Liter,
newsletter.
because
They sell in Europe. It's by liters.
Yeah, and the liter is more than Or less.
3.8 liters is a gallon,
Yeah.
so roughly 4 liters is a gallon.
Okay.
So
Well,
it's
like
$1.90,
4.
then a gallon in Germany
So
is,
it's like
So pretty close to
I've actually been a
$7,
member since like
$8.
2016
Yeah,
or
so
something, but I haven't been here.
yeah, when I was your age, I lived in Naples, Italy. My dad was in the military, a little younger,
Yeah.
5th through 9th grade.
Well, it's 7:03. Should we allow a little more time for,
We could start.
or we go ahead and start?
Is anybody online?
Yeah.
Hey, I think Angel said he was going to connect online. I know Jan is still
Yeah.
probably a little under the weather.
Yeah.
What are you looking for? Yeah, come on in.
You got to the right spot.
Hi.
Hi.
All right. Well, welcome everybody. Like I said, I know we have a few members that are not here. I have decided I'm going to put this thing back on because I had a little brush with COVID myself earlier this month, so kind of put the fear of God into me a little bit or something, I guess. So I hope that's not too distracting.
They said over 30,000 people could die from COVID. Can you believe that?
I had,
In the papers, in the New York Times.
yeah, I didn't feel
Incredible.
especially good for a couple of days, but it wasn't as
No.
bad as, it's sometimes depicted as being. But yeah, I had a couple of days and I'm
You
feeling
tested
okay.
positive, you did
Yeah.
yourself.
Yeah. I was, I think I tested positive on July 1st. Or maybe it was the
Yeah,
last
the
day.
virus is still around. I actually forgot my mask at home.
Well, I don't know. I think at this point it's kind of, at your discretion.
It's a talk,
But,
yeah, I wear it sometimes, go grocery shopping.
yeah.
Oh gosh, COVID.
Yeah, you guys start COVID, making me cough.
Anyway, welcome everybody. Some, maybe not so much new, but faces I don't recognize. So should we go ahead and go around the table and introduce themselves? I'm Doug Gooden.
Okay, counterclockwise, clockwise.
Let's go.
Sanford Pomerantz, I'm the one that keeps everybody sane here being a psychiatrist.
You got your work cut out for it.
Yeah, Thorsten Siegel and his grandson.
Brent?
Missy McCracken. I don't use my first name as CPA. I don't like to be collected on.
Okay.
Public libraries.
No worries. Welcome.
Mhm.
I'm Tony Castaneda.
I'm Gary, been around for about 8 years, so.
And I'm David.
Russell.
Okay. Before we get started, any announcements? Anything anyone wants to? Yes.
I watched the board that they put up, and I went up and questioned them about, the policies, and I started doing this audit thing, and I had to pull out of it. And so what I wondered is, does this club ever run anything over at Washburn in the astronomy deal that they have over there? They have a big deal over there. Did you guys ever get into that at all?
Are you talking about their planetarium? And
Yeah.
Yeah, we've associated with them and we've done things, but we don't normally do stuff with them. We're kind of a individual entity.
Do you have to
But
pay
we've
to
had
go in there
exhibits
now?
there.
Or is
No, I
nobody-
think so.
We've had exhibits, I remember.
Yeah,
We
Yeah, we-
do have a
we-
presentation.
yeah, we do. We do occasionally work with them in presentations and stuff. But most of the stuff that we do is kind of just within our own club.
Mm. I was just trying to figure out what it is. I appreciate the invite, because I've been to other groups, and they say, no, we just have a closed meeting. How does the
All of
library-
our meetings are open
Yeah.
and they have to be.
The library told me to ask.
I think it's required by our tax
I thought it was
status, isn't it?
too, yeah.
Yeah, we have our own observatory out by Eskridge, Kansas.
The city, this club did?
Yeah, it's called Farpoint Observatory.
Do they own a real estate?
Well, it's at Mission Valley High School, and we lease some property. So we have a 27-inch scope out there with some others. So we have our own observatory.
Oh, do you ever deal with lighthouses? No.
Lighthouses?
By the ocean, yeah.
No.
Astronomy doesn't deal with that.
That's
They have a lot of real
Not on a
estate
general
and-
basis, if the rain keeps up, maybe.
Yeah.
Uh,
I think if we start needing lighthouses here, then something seriously has gone wrong, but,
We're gonna get a bunch of lights.
yeah.
But light and stars.
We try to keep lights as far away from lights as we can get generally, because it kind of helps us see the sky. But speaking of Farpoint, anything new to say?
Well, let's see, about a week ago, Gary, led by Russ and myself, I was not the leader, Russ is the leader, we laid fiber between Kessler and the observatory, so that we could do some more things with the telescopes inside the observatory. So we did it in the heat of the heat wave last week, but we survived because Russ is young and has energy.
And
Gary and
Most of the work.
Gary and I had a point where like, good job, Russ, you're looking good out there, buddy. We sat in the air conditioning.
Yeah.
But Russ did a great job, so we have that, and just follow up some dot I's, cross some T's to get it going.
Yeah, well, I had good intentions on that, but something came up that I had to deal with in Manhattan, so I was out for the day. As far as upcoming events go, again, these are just something from the webpage. General meeting, of course, is, you know about it because you're here. The next public night is on Saturday night. My reading of the weather was that this would have been a little dicey, but apparently this is kind of,
It's showing
there's
clear
a little
right
bit of
now.
a clear window there, so
Yeah.
we may actually get a little bit of a possibility. And that means, of course, that we'll need help. Dave has been kind of coordinating a lot of the organizing people. So we have somebody for the 12-inch, right?
Russ
you're
is running the 12. You're doing a presentation in the observatory classroom. I'll run the 16. Gary's probably
Gonna be the mosquito target
the
outside.
mosquito target and do some constellation work.
Can you
for a
like
little
draw
bit.
them? Can you like draw them away? You know, kind of lure them.
Hopefully it'll be a breeze.
Yeah.
It's supposed to be not hardly any wind as forecasted. So anyway, so if anybody wants to help, you can reply to that email. I send it out to all the members. We have lots of little jobs. It's a good place if you want to come out. Also, just to learn, like hang around with Gary and help at that station and learn about some constellation and stars, or watch Russ on the 12-inch, stuff like that. You can pick up some things and learn about what NECAL has to offer. So, yes, a week ago, forecast was looking terrible, and then as always, it changes. So
Yeah.
right now, it's showing clear from 10 o'clock to 3 in the morning. So the thing is if you're coming out, we basically decide at the board meeting, which is, we hold a board meeting at Farpoint before public night, and then we post on our website if it's canceled or go. So you want to check that before you drive out to Farpoint if you're coming. Did I get all that right, guys?
I think so.
No moon. Moon won't be
No
up
moon.
Yeah, yeah.
till about 5 o'clock in the morning when the sun comes up.
Yeah.
And is there any prospect of us getting that comment? That's,
Have you?
It's getting lower and lower, and the trouble is it's gonna sink down to the southern sky here
So
before too
it-
long. So it's gonna be, I think, tough to even get to right now.
okay, well, that's too bad. I guess from my understanding, a physically relatively large comet.
Yeah.
So.
That's what I hear. The
It's also-
size of hell, Bob.
Yeah, so, I mean, that's unfortunate though, because that's kind of one of the things I was thinking about talking about, but I'll think on that. So anyway, that's the next one, then another public night on August the 20th, and something about that rang a bell, like there should be something, maybe an opposition or something going on about that time, so anyway. And the next general meeting is August 25th, so these are kind of our upcoming events.
What's the website?
The website is just www.necal.org.
What is it?
N-E-K-A-A-L.
Piece of paper, we can write it down for you.
Yeah. We could probably just find it here if we get it.
Maybe it'll do it.
It's the library.
Yeah, here it is. Yeah, this is our main website. You can see the announcement here on the public night. Not quite sure yet if that's gonna happen or
I
not.
don't know quite what public night is.
This, by the way, is a photograph
This coming
of,
Saturday night.
yeah, it's, if it happens, it'll be this Saturday night. This is actually a photograph of the observatory out there. And this telescope right here is 27-inch. It's actually in the process of being updated a little bit, so it's offline right now. But the building that just recently got wired for fiber optics is this one over here. It's got a 12-inch and a 16-inch telescope in it. So these are kind of our facilities.
Are these private companies that are paying for this?
No, we pay for it.
How is this going, huh?
Uh-huh.
Do you get donations or do you?
We have memberships, we have donations,
A few grants.
a few grants, yeah.
Where do you get grants from?
We have gotten grants from the Planetary Society, Mars Hill Observatory Foundation.
It's, not Mars Hill, it's Mount Cuba
Mount Cuba, that's right.
Astronomical Foundation out of Delaware.
Is it run by federal government ultimately? Is that what?
No, it's not a
it doesn't
government
do it
institution, it's a
federal.
private foundation.
Oh, that's cool.
Yeah.
Wow. Did
Yeah.
you build this?
Well,
They
kind of we're rebuilding it
Rebuilding
again, so, yeah.
Oh, we're architects. I mean, it's kind of hearing about being a member or something.
Mhm.
I don't mean to interrupt.
Well, this,
I don't have my glasses on, so
okay.
I can't see long ways. right
Yep,
now.
there's a seat up there if you want.
Oh,
Yeah, if you
okay,
wanna.
here, I was listening.
Okay. Any other announcements? This is not working.
From the beginning, or from current.
There we go. All right, so some of the things that are visible in the sky this month. August, of course, we're going to be in August here in a couple of days, so I figured I'd just go ahead and skip to August. One of the kind of things which we just talked about a little bit, which unfortunately I guess we are probably not going to be able to see, is pan stars, comet pan stars.
But it's gonna be low.
It's going to be, it'll be bright but low, right?
Yes.
I mean,
Yeah.
relatively bright.
And I'm not sure it's gonna be all
Coordinates
that
right
bright.
now.
Yeah? Anyway, it's supposed to reach its brightest on August the 4th. This is a comet that was actually discovered, I guess, by a satellite, or one of the first ones ever located on satellite imagery. So it's called Pan-STARRS. It's a relatively big comet, I guess. I remember seeing it back shortly after it was discovered. It hasn't been discovered for that long, right?
It's 2017, is that right?
Oh,
Yeah,
right.
it shouldn't be 27. That's-
Sorry.
I'll make sure I got the name right, because I'm trying to find
Yes,
the
it will be
coordinates.
discovered in 5 more years.
Yeah, right.
But we are ahead of the game.
All right.
So anyway, this will be one of the things that you can see this month if you're.
Is it in the morning or evening?
It's a late.
Well, right now,
It's 40
it's at declination 50.
40 degrees high
Oh,
at
it is
11,
50.
at,
It should be up in the
9
air.
o'clock.
It should be up
Yeah,
high.
well, that'll be quite
So-
easy.
so-
We should be able to see it.
Evening?
Actually,
Yeah, it
right
should
at,
be, yeah,
right
maybe.
at sunset, or right after sunset, when it gets dark, it should be good.
And
I was
it's,
thinking that was going down south, but
Is it-
apparently
so
it's
in the
just
evening in
starting.
the
to-
west? Or
yeah.
where?
I think it'll be kind of in the southwest, right?
It's at right ascension
Right now, it's gonna be
17,
up over
declination
there.
50,
Up
so
over there.
it's gonna be up in the air, yep,
That should be, we should be able to
50
get that.
degrees.
declination 50 out there.
I mean, if it's up high
Is
enough,
that
it should be up
for,
above all that.
7:30? Yeah, that'll be right.
Yeah. Well, anyway, this is one of
Yeah,
the.
yeah.
It's-
Yeah, I didn't know.
It probably wouldn't, it probably won't have much, I mean, it'll probably look a little like a fuzzy dot, I would
Its
guess.
magnitude is 15.
So,
Is that right?
15?
Yeah, yep, 15 mLs.
Oh, 15.
But keep in mind, that's kind of spread out, so.
yeah.
Yeah.
So because of that,
that's-
it actually looks more like a 17 to 18.
Yeah.
Okay, that's gonna be hard to find.
I don't think you'll see a tail unless
So
we
you'll
do a camera shot
We'll
of
maybe
it.
image it, but you probably won't see very much, but just
If we can get the
Sorry.
16 to go to Kessler, we might be able to do some
Yeah.
images.
Maybe you need it.
Another thing that August is
No,
really.
no rush, no rush.
Yeah, no pressure. One of the things I always like about August is, you know, I kind of like meteors, and
Can you see the meteors on it?
August is a great month for meteors.
Cool.
The best one, in my opinion, is the Perseids. They peak on August 1st. You can actually start to see a few of them even now, if you're patient enough to go out and find them.
The problem with this year is a full moon.
Yeah, but it should be still kind of far enough away to at least get some view of it. Anyway, if you want to find the Perseids, the radian is of course in Perseus, which is where the name comes from, which is relatively, at least for somebody like me whose knowledge of the sky is kind of, you know, C+, B-, it's a relatively easy thing to find. So if you want to look at them, you would look kind of right over here. This is Perseus right here. This is Cassiopeia, which is one of the easier constellations to see. So you just kind of look towards the ground from it, and you'll see it. One of my best memories is I taught a field camp I taught at KU's field camp one summer shortly after I was hired at K-State, and it was in Canyon City, Colorado, just outside of Canyon City, and you know, beautiful clear sky, very dark, and it was a great year for the Perseids, and it was like
Very high altitude.
yeah, and you could, some of them were good enough that you can actually see the little vapor trail that they sometimes leave. So it was very
Were you hired to
impressive.
do research for the University of Kansas?
I was teaching their field camp.
And in Colorado?
Yeah, the KU used to do a field camp in Colorado, so, because, you know, there's not a lot of geology in Kansas to see, so.
Interesting.
Anyway, so this is I think one of the highlights of August. The other one that you can see is the Kappa Cygnets, which are peak a little bit later. They're supposed to have a good year this year. The estimates I've been seeing are, you know, a relatively large number of these. This one I would find a little bit harder to find, but there's where the radiant would be right there. So there's Cygnus. Draco is a constellation that I'm always kind of able to piece out. And of course, this is Ursa Minor, the Little Dipper. So this one should be relatively easy to find. These, I think, actually persist. This is for a shorter period of time. Basically, the stream of material that the Earth's kind of passing through that produces these is a little narrower. So these aren't as visible for quite a long time, but also a really good meteor shower. So this is a good one to see. And of course, the peak Perseids are on August 14th. I guess I already said that. As far as planets go, a couple of things to kind of watch out for. August the 14th, Saturn will be at opposition. And of course, that means that it's opposite the sun, so it's fully illuminated and easiest to see. If you are really a night owl and you want to stay up very, very late, Jupiter has an opposition, or Jupiter will be visible kind of later in the day, and then Mars will be visible even later than that. So if you want to be up at like 2 or 3 in the morning, you can catch these. They're both kind of heading toward an opposition. Jupiter will be at opposition in a couple of months. Mars will be in opposition in December. So they're kind of heading toward that time when they're the easiest to see. But yeah, you'd have to be staying up pretty late to see these. These will be morning objects, though. You'll be able to catch some of these in the morning if you're, I guess, an early riser. The other one, if you want a real observational challenge, Vesta, the minor planet Vesta, will be in opposition on August the 22nd. Vesta, the last time it was at opposition, its magnitude was about 5.8. 5.9, which is just right on the cusp of what's visible to the naked eye. So if you are in a very dark spot and you have pretty good eyesight, you might be able to pick this one out. It would just look like another star, basically. But that would be a little bit of an observational challenge. But if you're kind of up for a challenge, that might be one to shoot for. Okay, so that's my highlights. Anybody else want to add anything or say anything?
Saturn will be up public night. It's gonna be low in the sky, but we might be able to see you.
That'd be good. I think it might actually be pretty good for the next public night though, right?
Yeah, next public night would be better. It doesn't show until 10:30ish,
Yeah.
11. And then the space station is gonna do 2 flyovers. The first one at about 8:41 is directly overhead,
Okay.
which is always fun to watch.
Yeah, that always. I saw a photograph somebody had gotten of it from somewhere like in the middle of a big city, and they've been able to photograph the space station, which is kind of cool. Did you have a question?
I saw a picture in New York Times today, and I'm trying to take the picture of it, show the federal government that these people allege that they have NASA and the Russians running a space center and wherever in the moon or something. They had 2 Russian astronauts and 2 U.S. astronauts.
I think right now on the space station there are 2 Russians,
That's what it said.
3 Americans, and a German. But yeah, unfortunately, one of the things I read earlier this week is that the Russians are going to pull out of the
Yeah, I got it.
space station consortium.
But realize that also the contract that everybody signed ends 2024.
Yeah, and they're not going to renew, right?
So,
So they don't renew.
Yeah, and that could be, I don't know, that could be
They might build
interesting.
their own.
Yeah.
most, the hope was that everybody was gonna, extend that to the.
Don't the
next 5 years.
Chinese have
I'm
one
sorry.
already? The Chinese have it.
They've been, I think they plan to
They,
build.
they don't have one yet, but they're wanting to build one, they're wanting to put one up.
I heard they have like everything. They just got to put it together and get it up,
Yeah.
which
yeah.
means it'll be crashing. Same
As
thing
long
on
as
the
we don't get
Russian.
hit by that first one.
Yeah. I was reading a history not too long ago of the Skylab program, and of course, Skylab crashed in about 1979 or something like that, and part of it landed on Australia. So Australia sent a bill to the U.S. Congress for littering for pieces of the Skylab that landed on Australia, and I think it was kind of tongue-in-cheek, but apparently the bill never got paid, so it's still this outstanding charge. Anyway,
There'll be a
well,
lot more of that coming up.
yeah. Yeah.
We'll
You know, we're
see
not,
the solar cycle kicks up.
Yeah, well, and it's not just the solar cycle, when you get somebody like Russia who shoots their satellites and causes thousands of pieces of debris to be littering the field, then your chances of running into those things are gonna cause more satellites to come down.
yeah.
Is Skylink messing up some of our observations, like your?
Yeah, I'll tell you what, well, Elon Musk is doing his best to kind of keep us wiped out of being able to do this work, because I tell you, I've looked at a lot of images, and the number of satellites that are showing up in a lot of the images that we take are pretty significant, and they're getting worse.
Yeah.
And Amazon wants to do one, and somebody else
Oh,
wants
yeah,
to do one.
I think Bezos is in there too, isn't he?
Yeah, there's 2 or 3 that want to do
Well, the Skylink one, there's what, over 1,000 of them up there now, aren't there?
I think there's several thousands.
Yeah, I was gonna say, if you ever see the trail of them, it's pretty impressive
Yeah.
and depressing.
it. And they're talking about their I saw a video talking about the V2 version 2 satellite, which is a lot bigger.
Oh,
It's
yeah.
like twice as big as the one
Yeah.
that we got.
You'll be able to see them.
I have a former student that works for a company called Planet, and they launch imaging satellites, and each one of them is about this big. And seriously,
Mhm.
they're about the size, they
Yeah.
would fit in a shoebox.
Yeah.
It's CubeSat.
But there's, they've got, their constellation is over 100 of them.
Yeah. Well, it's just like when people put up lights, people don't take down lights, they always put more up, but they
Yeah.
don't take any down, and fortunately, gravity will eventually take some of that out, but, I don't know what we're gonna end up with by the time we get down the road.
Yeah.
I won't have to worry about it, but other people will.
I know my Earth observation hat likes those little planet satellites because they really return some good data, but you know, the other part of me is like, no, we can't have this. So.
Well,
It's a little bit of a conflict.
It's a mixed bag.
Yeah.
Have you ever tried anything from Coke Industries, KLCH Industries? Have they ever,
No,
you ever approached them at all?
we have kind of a limited amount of places that we go. Actually, we're pretty self-sustaining.
Yeah.
We've got a small amount of overhead costs, so we rent utilities from we pay utilities to the school, and we get part of what they've got going, so it works out okay. I mean, we run pretty cheaply, frankly. Once you get the big investment of getting the building going.
I don't know, they gave out a couple, I was on the internet today and I seen it, they gave out a couple $1 million, and it's for startup kind of deals and arts and other, you know, the sciences and stuff.
Yeah, well, ours has been around for a while. We're not exactly a startup at this point.
I think they're looking for people that are in, this is considered to be the arts, you know, science.
We actually have done pretty well. I mean, we got $40,000 during the last year for a grant, so.
That's pretty good.
That helped quite a bit. Of course, it was all earmarked toward the equipment.
Okay, well, I figured tonight we'll talk a little bit about I think probably the most significant thing that's happened in kind of astronomical science in the last few weeks, which is the James Webb Space Telescope coming online. Of course, we had a very good presentation on this, what was about a year ago, right? Maybe not quite a year ago.
Yeah.
From
Bruce
Twarg, a professional astronomer, I guess retired now, but a professional astronomer from KU, who gave a very interesting talk about sort of the history of the James Webb and some of its characteristics and all that. But at the time, it hadn't even been launched yet, and of course, it was I think there was a lot of tension in the astronomical research community because it was a very, very complicated thing. Right? Getting a rocket up into space is not exactly rocket science. Well, it is rocket science.
It was sucking up a lot of the budget. That was what a lot of people were concerned about.
Yeah, and it, you know, but getting something launched is always a little bit fraught. You know, rockets still don't occasionally fail. And then once it was in space, getting it out to where it was supposed to be, which it's quite a long way from the Earth now. And of course, because it was so large, it had to be folded up. You know, when the Hubble Space Telescope was launched, it was just launched as a thing, right? It was in the back of the space shuttle, basically, and they just sent the space shuttle up and kind of pushed it out the door, really. Getting the Webb in place was a lot more complicated, and it had to unfold, and there was all these things that had to happen, and I know it was probably, if you were directly involved in that, there was just tremendous amounts of tension. But it all worked. It all worked perfectly. And this thing is now operational. It's at its kind of parking place now, and it's...
we call it the target.
And and I guess it did have one little incident. There was a micrometeoroid that hit it.
It's not one.
Has there been more than that now?
There's been several.
Yeah.
And the latest one of them was a lot more significant than the others. But they, I knew they gave thought to this prior to, and they, you can isolate the one mirror that's got the hit and just use the others. But the problem is it's gotten hit so many times with micrometeorites, and then the latest one took out a section of that mirror that they can't no longer use.
Oh, I didn't know
and they
that.
can't fix it.
Yeah, that's
There's no way to fix it.
That's one of the problems with this thing is, the Hubble is in orbit around the Earth, and it's actually in an orbit that's accessible. So people can go up and work on it, which actually happened. It was, optically flawed when it was first launched, and they repaired it. This thing is far too far away. It's theoretically possible to get people out there, but practically it would probably make going to the moon look simple by comparison.
Well,
So yeah.
How many components? Like if one of the mirror components gets hit, you're
Yeah,
saying
yeah.
it knocks out, but so how many mirror components are there?
72, is that right?
Something like that.
There's quite a few of them.
Yeah, it's all these little segments here.
Bunch
You
of
know,
hexagons.
Yeah, I mean, the mirror is not one solid piece like
Right.
it is. It's made up of little sub things. But anyway, it's in space and it's functioning and it's returning data. And I think it has a lot of people, at least the professional astronomers that I know, very excited about it. So I thought what I'd do tonight is just talk a little bit about some of the early results and some of the pictures, which I'm sure many of you have probably seen already. But one of the things that's really struck me is that, you know, the thing has been operational for what, maybe 2 weeks, 3 weeks, something like that. There's already published papers from the results. I'll show you a couple papers that are the very first publications to come out of this. So that in itself, in my mind, is a pretty remarkable thing, that this thing is already returning publishable quality science after being in business for what, less than a month. Anyway, here's the kind of odyssey that it went through to kind of get out to its location. People have seen these sorts of things. This was a timeline of it once it was launched, and it took quite a number of days to get out there. What you don't see on this was, I think the project was first started in about 1996 when this was first proposed. So this thing was about 30 years in the making. And I think that kind of sometimes gets lost in all this. It went through all these different design phases, and that's not particularly uncommon for anything to do with space technology. It takes a very, very long time for this to happen. One of the things I did earlier in my career, one of the things I do is Earth remote sensing, right? Imaging the surface. It's like astronomy backwards. Instead of looking at the space from the ground, we look at the ground from space. And one of the things that I got involved in very early in my career is a satellite system that could measure carbon. And it'll be launched year after next. So this is, 25 years in the making. So I have a slight bit of experience with this kind of thing, and it makes me incredibly impressed that they were able to, put this in just extremely complicated machine out into space like this. So the technological capability that went into this, I think, is absolutely mind-boggling. But anyway, the first image that was returned is this one right here. This is the one that was in it, when the president did the press conference. This is the one that they showed. And then we'll take a closer look at it here in a second. There's some really interesting stuff on this, but this was basically an image of a galaxy. And we'll take a little bit of a closer look at it here in a second, because there's some pretty interesting things going on. You can already kind of see them, right? See how all this stuff kind of looks a little weird. In fact, I saw a few discussion groups of people who were convinced that the mirror was flawed, that the instrument was not working. It's working just fine. We'll talk about that here in just a second. But I also want to kind of pay a little bit of tribute here. The web is now the golden child and is getting all the attention and all this, but we should pause, I think, a little bit and appreciate this thing. This, of course, is the Hubble Space Telescope. It's been in orbit, I believe, a little over 30 years now, 35 years, something like that. And it is a pretty remarkable instrument in and of itself. I think it often now is serving as a point of comparison to the Webb, but it's a pretty remarkable thing in and of itself. It was really built, the Hubble is a general purpose telescope, right? It's actually a general purpose observatory is really what it is. But it was built to, as the name would kind of suggest, to define, among other things, one of its major purposes was to define the Hubble constant, right? Define the rate at which the universe is expanding. And it did kind of a brilliant job of that. As data from it has been instrumental in kind of fixing the value of that constant, which is fundamental to kind of understanding cosmological science, basically. I like this one a lot. This is the one of the Hubble deep fields. This is actually I believe the ultra deep field, isn't it? But what's interesting about this is that every dot you see on there is a galaxy. There were no stars. Well, there's stars, but the stars are all in galaxies. And this sort of thing was pretty revolutionary stuff when it was first introduced. And so, like I said, the Hubble was designed to, well, for many things, obviously, again, a general purpose instrument, but one of the major purposes of it was to define the Hubble constant, right? So if you kind of think about the sort of history of the universe as a whole, the Hubble got us back to right in here somewhere. And one of the things that the Webb was designed for is to kind of go a little bit further than that, to try to get a little bit back further into the kind of original history of the universe. The other thing that I kind of was just completed, actually, is this project with using Hubble data to define distance scales. This is actually follows from this work on the Hubble constant. And one of the things you could do with it is actually see details in other galaxies, including things like variable stars and stuff that are used as mileage markers, basically distance indicators. So this was one of the major purposes. This is all the cosmic kind of mile markers that have refined understanding of how far away things are, which is kind of a crucial thing if you want to figure out how fast it's all getting further and further away. So this was another thing that the Hubble really was used for. So like I said, the Hubble gets us back, back around in here somewhere, I guess. What the James Webb, one of the things the Webb was designed for is to get a little bit further back in time than that, into a time when objects were not formed yet, basically. And so one of the things that means is, first of all, it's a considerably larger instrument, right? So compared to the Hubble, launched in 1990, mirror size about 2.4 meters, which is pretty good sized. Compared to that, the Hubble was 6.5 meters. Of course, it's this segmented mirror. One of the things I found really fascinating about this graphic is, look at this. The mass of the Hubble, about 12,000 kilograms, right? The mass of the Webb, which I don't know if you've ever seen it, mock-ups of it, but the sun shield part of it is about the size of a tennis court, right? So this thing is really, really big. And yet it weighs about half, almost exactly half its mass, I should say, is about exactly half of what the Hubble mass was. And it kind of represents sort of a different philosophy in instrument design. But here's the other thing that kind of strikes me about this, other than the differences in the mirror size. This is operating temperature right here. It's operating at minus 230 C. Minus 278 C is absolute zero, right? That's coldest that anything could be, right? Mm-hmm. So I think that's right. Yeah. I should know this stuff. Anyway, so this is operating at extremely low temperatures, much lower than the operating temperatures of the Hubble, and that actually enables the thing that is the most different about, at least I think, the most different about the Webb versus previous generations of space telescopes. That it's designed to operate in the infrared part of the spectrum, right? So the Hubble, most of its instruments were optimized for the visible and the near infrared. And infrared is kind of a misleading name because it's a very wide band, right? The visible piece of the spectrum, if you think about the spectrum as a continuum, and on one end is really short wavelength stuff like X-rays, right? The other end is really long wavelength stuff like microwaves, which is kind of a misleading name, and television and all that stuff. The visible light band is almost exactly in the middle of that, and it's a very, very narrow little band, and it's defined, of course, by human physiology. It's what our eyes are sensitive to. And the Hubble instruments are, for the most part, visible and operating in that band, and then a little bit into the infrared part of the spectrum. The Webb instruments are designed to operate much further out in the infrared part of the spectrum. They operate in a part of the spectrum that we humans perceive of as heat, right, thermal, and even a little bit further than that. And there's actually a pretty good reason for that. And so here's kind of a graphic that sort of shows that. There's the wavelength range of the Hubble, a little bit of the ultraviolet, all the visible, a little bit out here into the infrared. Lots of important stuff happens there, kind of physically, right? Here's the Webb. It's operating way out in the infrared part of the spectrum. You can see that, the extent of it's got these 4 instruments on it, right, which kind of cover the spectrum in these overlapping pieces. And the longest wavelengths it does is 28,500 nanometers, which is 28 micrometers. Anyway, it's out even a little bit further than the thermal part of the spectrum. And when I first was reading about this, I was a little surprised by that, because I thought, well, why is it that they're so deeply interested in things that are heat, right, that are thermal? But it turns out it's exactly in line with what the purpose of this thing is, which is to kind of get back into this really, really old, get back to a very early part of the universe. And of course, we know that the universe is expanding, right? As everything expands, its spectral response gets redshifted, right? It gets shifted to longer and longer wavelengths. And again, redshifting, I think, is a little bit of a misnomer, because you can shift things way past the red part of the spectrum. The red, of course, is the longest wavelength of visible light. It's the longest wavelength of light you can see. And so what it's basically doing is, what this kind of enables it to do, these sensitivity to very long wavelengths, is it makes it able to look a long way back in time and catch some of these deeply redshifted, so when they were emitted at their original source, they were probably emitted at much shorter wavelengths. But the fact that they were, they were part of this expansion means that they've been shifted down into very long wavelengths. So the reason why the Webb is optimized to see in the thermal is because it allows it to see back in time. There are some other advantages as well. One of the things that is often a problem in imaging is dust, right? And dust is usually a very good optical scatterer, because of the size of the particles. Scatters optical wavelengths really well, but thermal wavelengths not so much. Scattering is often a function of the size of the particle that's doing the scattering, right? So it allows you to kind of see through dust a little bit better. But the real purpose, as I understand it, is that it basically allows viewing things that are very deeply redshifted. But also, I think you've got to kind of bear that in mind when you start looking at some of these images. The images that you'll see, that deep, that original image we looked at, and some of these others, they have been processed so that we can look at them, right? They've been kind of enhanced so that we can look at them. But what you're seeing there is wavelengths, which are actually what's being depicted is wavelengths of light that are not visible to the human eye. Basically, the human eye is not sensitive to that. I like to think about sometimes of what we would look like if we were able to see thermal light, and you'd have to have a really huge head because you have to have really big eyes in order to see it. So anyway, here's kind of some examples then. These are some of the early infrared space telescopes. There's been infrared space telescopes in orbit for quite a long time now. This is the same frame. This was WISE. This was the first thermal infrared space telescope that was launched. So you can see it's pretty pixelated there. You see these fuzzy blobs, basically. This was the Spitzer Space Telescope, or IRAC as it was originally called. It's operating about 8.6 micrometers, right? 8.6 millionths of a meter is the wavelength. So it's longer than this one, but still in that thermal part of the spectrum. Same field, right? Now we see a little bit more detail, right? And then this is the Webb with its mirroring instrument. Its wavelength is kind of splitting the difference between these. But look at all that detail. And that's just a artifact of the fact that this is a much, much bigger mirror, right? So it's able to resolve things in much more detail. So now you actually can kind of see that these are stars and that there's much more fine detail. So this is the kind of thing that the web really offers, is the ability to see things in much more detail. Here's another example. This is the Large Magellanic Cloud. This is the Magellanic Cloud as a Spitzer, and you can kind of see it there. This is it with the MIRI instrument, the web MIRI instrument, and you can see again much more detail. So the Magellanic Clouds, of course, are these kind of galaxies, I guess, galaxies, but not galaxies with a spiral structure to them. They basically just look like
There's irregular satellite.
irregular satellite images. There we go. I've seen one time, and it was pretty interesting. So again, this kind of shows you that the technological capability of this thing is much more. It adds much more detail to what can be observed. Here's some others that kind of show that. This is a